Welcome to the final recorded video for the class, talking about how to divide expressions that contain polynomials. Now in part 1, let's begin by reviewing how we simplify fractions, remembering that division and fractions are very closely related to each other. If I had, for example, 15 over 3, or put another way, 15 divided by 3, this could be simplified just by literally dividing 15 by 3, giving me a result of 5. Put another way, if we think about 15 as 3 times 5, if I take 3 times 5 and then divide out 3, we talked in a previous episode that if you multiply by a number and then divide by that same number, the actions of multiplication and division cancel each other out. So this multiplied 3 and this divided 3 cancel, and therefore 15 divided by 3 just gives you back that 5. Now let's take that same idea into 6x squared divided by 3. If I think about 6x squared as being 6 times x squared, as being 3 times 2 times x squared, then that multiplied 3 and that divided 3 will cancel each other out. And I will be left just with 2 times x squared as the result. Let's take that same idea into this example. If someone gives me the fraction 6x squared, and I want to divide that by 3x, then I can think about 6 as being 3 times 2, so I can see a multiplied 3 inside of 6. And I can think about x squared as x times x. Now, a multiplied 3 and a divided 3 cancel each other out. So this multiplied 3 followed by this divided 3 will cancel. Also, this multiplied x and this divided x will cancel each other out. So this multiplied x and this divided x will cancel. So all that will be left is the quantity 2x in this expression. 2x in the same way that 15 over 3, 3 times 5 over 3, the 3's canceled and all that was left was the 5. Here, all that will be left is the 2x in the numerator. Now, by contrast, simplify 4 over 16. We remember that we can simplify fractions by dividing the numerator and denominator by the same value. So 4 divided by 4 would give me 1. 16 divided by 4 would give me 4. In this case, I would have 1 out of 4 as the simplified version of 4 over 16. If I think about this in terms of a multiplication and a division that are canceling each other out, I can think about 16 as 4 times 4. And if I cancel out those two 4's, I'm left with a single 4 in the denominator of the fraction. When I'm left with only a quantity in the denominator of a fraction, we fill in the numerator with just a 1. The same trick works in a situation like this one. You can think about this as 2x divided by 1. But when you divide a quantity by 1, it doesn't actually change the number. That would be the difference between an example like this one and an example like this one. When you cancel all the quantities out of a portion of a fraction, a 1 is left behind in that position. It's just that if the 1 is in the denominator, a 1 in the denominator doesn't do anything. Dividing by a 1 doesn't do anything to the number. Let's take that same idea into this example. In this example, we're asked to simplify 7x cubed divided by 14x to the 5th power. So I could think about that as 7 times x times x times x in the numerator, and 7 times 2 times 5 copies of x multiplied together in the denominator. Now this multiplied 7 and this divided 7 will cancel each other out. Also, this multiplied x will cancel one of these divided x's. This multiplied x will cancel this divided x, and this multiplied x will cancel this divided x. I've canceled everything in the numerator, so what's left behind in that position is the number 1, and in the denominator I'm left with 2 as well as 2 copies of x multiplied together, 1 over 2 x squared. That would be the result of simplifying this expression.